Hello friends, this is lesson 10 of NLP, Natural Language Processing. In today's lesson we are going to cover the following topics. First we'll be discussing about what is machine learning, then machine learning on text, types of machine learning, and then we'll be talking about knife based classification, and I will give some examples for them. Let's start with the first topic and see what is machine learning. So machine learning is a process of giving the ability to machines such as computers to learn from given data without explicit guides by the user. So this is called machine learning. Giving the ability to machines such as computers to learn from the data without explicit guides by the user. Now the process is complex, which uses statistics and probabilities to find the base patterns in the data and reach the best solution or take decision. Now giving this ability to machines, it is not that much simple, it is a little bit complex. It is based on statistics and also probabilities, and then the model will be trained and will be able to predict the output or take the decision or find the solution. Machine learning is a game of correlations and relationships. So in short, we can say machine learning actually it finds the relationship and correlation between the features, the inputs what we provide, and based on those relationships and correlations it will predict the output or find the solution for the data, right? Whatever input we give, so it finds some relationship between them. And then let's see here, machine learning on text. Machine learning on text is the process of training the model machine with instances of data. Here the same will be training the data, the model with training data, and that training data is considered as instances of the data. The rows and the columns will be considered as features, right? So these instances are used for training the model in order to fit the model which used to make prediction of unseen instances. We'll be training the model with instances, and then we will apply unseen data or instances, and we will see how the model predicts or take the decision. And here in text analysis, instances are nothing but the document, or we say corpus, right? The model needs some inputs like features, predictors, they are all the same, which describe instances in order to predict the output. This is important, friends. So instances, or we can say features or predictors, these things are important given for the model. They are all applied for model as a training data, and after that the model will be able to predict the output, and that output is called the response value, right? So let's see here what are the features in document. So we have the document that will be, you know, that it can be split into paragraphs, and then that can be split into two sentences, and then we have the tokens. Now document level features, what do we have? Like we have metadata, author name, title, date, we have paragraph, sentences. These are the features in document level. And if we go to word level, and word level, what do we have? We have forms like capitalization, uppercase, lowercase, all those things. And then we have the vocabulary, the meaning for all that. Maybe the meaning is here the frequency, how many times that word is repeated. Like we did study different types of frequencies, like 1 hot was there, right? Or frequency of was there, TF IDF was here. So that will be considered as a value for the word. And then we have the frequency, how many times the word is repeated, right? So these are called the word level features. Now let's see here different types of machine learning. In general, we have two types of machine learning, friends, and they are based on data types. They are classified based on data types and computations level. Like we have mathematics, computation, and data types. Based on these three types, they are classified. So the first type is called supervised machine learning. So supervise, as the name suggests here, you have to supervise the machine. Means suggest or learn to the system work its own. So here the user is involved while training the machine. It is supervising the machine. The machine learns from the training data that is labeled. This is another important thing, friends. In supervised machine learning, we need labeled data, right? So the data for training and also for testing what we apply, we need labeled data. So supervised machine learning models might try to find the association between the, for example, here person's health features. Like what do we have? For example, these are the features, friends. These are the features. If a person is having fever, dry cough, tiredness, headache, sore throat, and so on, these are considered as features, then what will be the response? The response will be either yes or no. If the person is having these things, so the answer for that is yes, it means the person is infected coronavirus. Otherwise, it will be no, means the person is not infected. So these are the response values, and these are called as features, or we call it as labeled, because we said supervised machine learning need labeled data. So these are called labeled. Sorry, these are called the labeled, yes or no, and these are called the features, right? And now here in unsupervised machine learning, so here also you can see that no labeled data, so we don't have labeled here. You provide the data to the system, let the system does the rest of work. Here we are not supervising the machine, but the machine itself is taking decision, right? So it takes all the predictors, means the features, the inputs, and finds the relationship between them by reducing the dimensions and aggregating similar values, and that is called clustering. And this one is called dimensionality reduction. In unsupervised machine learning, here we don't have labels. Label data is needed, not there. So the whole data is applied to the machine. So the machine is taking the decision. How it is taking the decision? It is finding the relationship between the features, and based on that, it is then giving the response, right? And how the relationship will be found, and that is like by reducing the number of dimensions and also aggregating similar values, which is called clustering. It will be clustering the values based on some similarities. And then let's see here a type of machine learning which is called naive Bayes classification. So naive Bayes classification model is a supervised model, means it needs label data. So model a group of extremely fast and simple classification algorithms that are often suitable for very high dimensional data sets. If we have high dimensional data sets, so we will be using naive Bayes. It is recommended naive Bayes model. It is a group of extremely fast and simple simplification algorithms. It is a probabilistic classification in supervised model, means needs label data, as we discussed before. So this is the formula here, friends. P, probability of labels given the features, is equal to probability of features given the label into probability of labels divided by probability of features. These things I have already explained in my data science lectures, friends. For further understanding, you can refer my data science lectures also. Now let's see all these things practically here, then you will better understand. First of all, I am executing this part for importing the NLTK. Then we talked about machine learning, the ability to give into machines like computers to learn from the data, right? This is called machine learning, and we say that the process is complex because here it will be using statistics and probability. And then we have the types of machine learning. Here we said in generally we have two types, supervised and unsupervised. In supervised, again, it is classified into two types. We have classification and regression. And unsupervised, again it is classified into clustering and dimensionality direction. And if you come to here, supervised machine learning. In supervised machine learning, we said we need the labels. Label data is considered here. If labels are not there, so that may not be working here in supervised machine learning. For example, this is an example. If we consider an email, there we have either, we will check whether the email is either spam or ham. So this spam and ham is considered as a label, and the remaining inputs are considered as features or predictors, we can say. But one thing you have to remember, the labels are not always binary. You will consider always they are binary. Sometimes they are not binary, they are categorical data, like we have discrete values also, like deciding news relates to whether it is sports, technology or politics. So here we don't have 2 values but 3 values, right? So like that, if we have, we'll be using supervised machine learning. So here you see the figure, you can better understand. Here we have the training data. Will be first of all, feature extraction will be applying. Here feature vector will be designed, and that data will be fed to the model, and the model will be considered the labels of that, right? And based on the label, the data will be classified. After classification, what will happen? We'll apply new document. So this new document is also called unseen data. This data is seen data because this is the data which is trained the model with, but this is the data which the model does not see yet, right? So unseen data comes, and again feature extractions will be done. Then predictive model. The model will predict here the output based on these labels and based on this training data which is coming. It will be classifying this data based on this data and based on these labels, right? And then we will be getting classification result here. And now let's see here, we'll have an example for gender identification. Like we have different names, male's names and we have female name, and how to identify whether a name is female name or male name. This identification, friends, it is simple and easy if you consider the language is like Pashto, or we consider a language called Arabic. In these languages or Persian, it is very simple. From the name you can understand whether the name relates to female or male. But if you are considering English names, there is something difficult. There it is somehow difficult, because in Arabic we have different letters, and those letters with the name ends with those letters or alphabets, then we consider as a female or male. But here it is difficult somehow. But let's see here, if you consider male names ending with these things, if they are ending with these letters, they are likely to be male, but not always. And also female names ending with these letters, like, right, and they are likely to be female. Now based on this condition, I have defined a function here called tag gender. We will pass a name here, and we will be considering the last letter of the name. If that last letter is a single letter, last letter, and slicing, if you remember these things, you know that in list we did talk about these things. If it is equal to A, or it is E, or it is H, that will be considered as a female. Or at the same time, the last 2 letters will consider. And if it is YN, if it is NN, or it is EL or HI, that also will be considered as a female. The remaining things will be considered as a male. Let us see here. Okay, executed. Then I am passing this name Julia. Since it is ending with this A, it is returning this letter called female. But if you come to this one and send this, it is saying male. The same time, if I type like Johnny, since this NY, it is in this list, again it will be returning this one. It will say it is female. Yeah, sorry, first this one is executed, right? Sorry, it is not Y. Like if we have yeah, let me change this one to not NY, right? It is better. And now you see here, what do we have? Johnny, let me change it. Yeah, now it is female. So it is taking the decision based on the last single letter or double letters, like that. Or maybe some people consider the number of characters, how many lengthy names are there, they are considered as male name, small letter, number of characters they will be considered as a female. Based on that you can also take decision, or based on the last characters, 2 characters, 1 character, or 3 characters in English. But in other languages it is somehow different. There in NLTK there is a corpus called names. We have a set of names here, document their names. Let me read those names from the corpus. So I say from NLTK corpus import names. Yeah, the names are important, and there are 2 documents. The first document is male names, and then we have female name. Let me print some of those names. You can see they are called as male names, right? You see here it is ended with this letter, here it is, you see different names are there. And then if you come to this name for female, these are the names for females, right? So we have 2 documents, male names and female names, and we'll be considering the last character of the names, and based on that we'll be training our model or algorithm. So this is the function gender feature. The name will come here, and based on the name it will be returning the last letter of the name. Like here I am passing this name, it will be sending me the last letter of that. So what we'll do here, I am combining and labeling the names. First we'll combine, because we have 2 documents, male names and we have female names. I will be combining, and at the same time I will be labeling them. So I am creating a for loop. One by one the names are extracted from this file and the label is assigned to them. Male, 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 they are all assigned male, and the data which is read from this file, and those will be assigned the letter female, and they are shuffled here. Like randomly we will be shuffling the names, and let me print, and now they are combined. You see here we have male and we have female, like that, right? Now the next step is feature extraction. How can we extract, and now how can we identify the name is male or female, because now they are mixed. I will be passing these things to my function. I will be reading the names, because this names now has both the names, males and females, and 2 things we are extracting from that. N means names and G means gender, and I am passing N means names to the function, and the function will return the last character of that, and based on the last character and also the gender for that, right? And then we'll split the data into training and testing data, right? It means we are starting from 500 till the end as a training data, and from beginning to the 500 that will be considered as a test data. Yeah, and now we will be using the model naive Bayes model. So naive Bayes model, we said it is a probabilistic classification model and also supervised model, because it needs label data, and we have provided label data here. What are the labels? Male and female. These are the 2 labels, right? We are providing, and here is based on this it is working. Probability of labels given the features is equal to probability of features given the label into probability of labels divided by probability of features. So this NLTK, if you are using NLTK, you will be calling this one naive Bayes classifier, and there we are training the data, and this training I am taking from there, right? So that part is executed. Let me execute this part. And now see here the last letters and the labels. The last letters and the labels, they are all combined like this. Now let's see here, we'll pass a name like this one, Jack, right? What it returns? It returns male. And here, if I pass this one, we'll see it is returning female, right? And now let's see model performance here. For seeing the model performance in classification models, we are just considering the accuracy of the model, how accurately the model classifies the data. So this is my classifier and this is testing data. We will see the accuracy, how the model is classifying the data. It is around 77%. So it is good, right? Because 77% is a high accuracy, so the model is classifying the names or the data correctly. And then let's see here most informative features. If you want to see, so from our classifier we will be calling the function show most informative features. 10 of them I want to see. You see here, these are the most informative features, right? Here the names ends with a character or a letter. So 36 times more names relate to female and the remaining remains to male. But here if you come to this name, names ends with K letter, 32 times we have more male names and then female names. You see like that we have like these things. The next thing, let's consider the last two characters. I'm changing the model. I say okay, I'm not considering the last one character, but the last two characters. Now let's see how the model responds and whether the performance increases or not, the accuracy. Okay, this time you are considering the last two characters and also splitting the data into multiple parts: training, developing, and then we have test, right? Here now we have 3 partitions, not 2 partitions, but in previous we had only 2 partition, training and then we have test. Here I created another partition also, develop, test is also there. And now I am calling my function here for feature extraction, feature here gender, and calling my this function too. Now let's see here and see the result, how it returns. Yeah, the model is trained here. We trained the model here, right? And now testing the model. First I am testing with development test, and let's see, and it is how much? It is almost 80%, so it is increased, the accuracy is increased. And let me test the model, evaluate the model here, and you see it is 81%. So what we have to do from this, you might understood that instead of having 2 splits, it is better to have more splits. And one thing else, instead of considering only the last character, it is better to consider the 2 last characters, right? So you can also change the classifier. Here I am using decision classifier and before it was naive Bayes classifier, right? So these are the changes we brought and we got in our model. So I hope you understood all these things, friends. These were the topics what we discussed. These are the topics. I hope you understood all these things. Thanks, friends.